So we're going to start notes today on the last section, which is section 3. And this is two very specific distributions called binomial and geometric. Basically, we're going to be calculating probabilities. The reason I want to show you this front page is with binomial and geometric, there are things that you're going to have to learn how to do on the calculator. So there's a lot of stuff on the calculator. And then also on the formula sheet, I've shown you this before. I don't know if you've seen it though. There's a binomial and a geometric section. And you'll notice there's a whole bunch of formulas. So there are 6 different formulas. They're all on the formula sheet though. So we're going to work a lot today with these formulas and with numbers. This is where I need you to be right now. Today we are going to talk about the binomial distribution, and then when I see you next time, we will talk about the geometric distribution. So first of all, a binomial distribution. One thing I want you to know about it is that it is a discrete variable. It is discrete and numeric. So x can take on 0, 1, 2, 3, but it can't take on 1.5 or 1.77. Okay, so first I want to talk about what is a binomial random variable, then we'll talk about the conditions. So what is a binomial random variable? We are looking for the probability of a certain number of successes out of n trials. So something like, I have 10 trials, what is the likelihood I get 3 successes? Or at least 3 successes. That's binomial. So what's really important is you have a fixed number of trials and you're looking at a certain number of successes. Now, there are 4 different conditions. What you need to remember for binomial, the conditions are bins. So here's what I mean by that. B stands for binary. So there needs to be 2 results only. Success and failure. I is independent. Your trials need to be independent. N, this one's a little bit of a stretch. N stands for number of trials. And what I mean by that is it needs to be fixed. And then S stands for same probability of success. So an example here would be, I flip a coin 10 times. What is the probability I get 2 heads? That's a binomial variable. It's binary because there's only 2 results, heads or tails. The flips are independent, so it doesn't matter what I flip the first time. It has no effect on the second flip. I'm flipping 10 times, and then the probability of heads is the same for each flip. That's binary. Same thing if you roll a die. I roll a die 10 times. What's the probability I get 2 6s? That's binary. 6, not 6. Okay, possible
How is it discrete if it's like not numeric?
Because x takes on numeric values. So we are specifically counting the number of 6s, or counting the number of heads.
Oh, you're counting the number of successes,
Counting.
so
That's the variable. Good question. Possible values. If we think of flipping a coin and getting heads, I can get 0 head, 1 head, 2, so on and so forth, all the way up to n, however many trials there are. So if I flip a coin 10 times, I can have anywhere from 0, 1, 2, all the way up to 10. Okay, parameters. I'm going to do this off to this side. If we think of a normal distribution, what are the parameters for a normal distribution? So in other words, when you write normal, what are the 2 things you always have to write along with it that define the distribution?
Mean and standard deviation.
Thank you. Mean and standard deviation. So that's for a normal distribution. For a binomial distribution, there are two parameters. The first one is n, which is the number of trials. And then there is p, which is the probability of success. So like a normal distribution where you always have to list the mean and standard deviation, with binomial you always have to list n and p. The most common mistakes, there's two of them. The first, really this is the most common. The most common mistake that students face is that they don't recognize a binomial distribution. The question is never going to say, this is a binomial distribution. It's going to show context, and you have to recognize that it's binomial. And so, in particular, binomial distributions come up a lot on multiple choice. And that's where people don't know how to do them. So that's the biggest one. The second mistake that people run into is they write binomial out, but they don't list n and p. So if you write binomial and then use your calculator, you're not going to get full credit because you didn't give n and p. So before we go to the calculator and learn how to calculate some things, the first thing that we need to be able to do is recognize a binomial distribution. So that is what we're going to do first. Determine whether the random variables below have a binomial distribution and justify your answer. So here's what you're looking at. Are we looking at a certain number of successes in a fixed number of trials? And then do all four conditions apply? So A, we roll a fair die 4 times and we count the number of sixes. So first question, are we looking for a certain number of successes in a fixed number of trials? What's our fixed number of trials? 4, right? We roll the die 4 times. Is this binary? Is there success and failure? What's our success?
6.
Roll a 6. What's our failure?
Not 6.
Not a 6. Does our probability of success stay the same?
Yes.
Right? Are our rolls independent? Yes. So A, we would say yes, that one is binomial. B, shoot a basketball 20 times from various distances on the court, and Y is the number of shots made. Okay, do we have a binary variable? Success and failure.
Yes.
What is success?
Make it.
You make it, right? Failure is you don't make it. Are they independent? So the first time that I shoot, is that completely unrelated to the second time that I shoot?
Yes. Well, it says various distances, meaning.
I am not a basketball player, but I think an argument can be made that if I stood in the same spot and I kept shooting, what?
You tired over time.
You might get tired or you might get better, right? Like I would theoretically hope that you're making adjustments to try to be more likely that you would make it in. So probably not independent. Is the probability of success the same? No, because of those various distances, right? So this one is definitely not binomial. And then C, observe the next 100 cars that go by and let C be the color. Binomial?
No.
No, why not?
There's more than 2 options.
Yeah. So no, this is not a binary variable. It's also not numeric. Okay, what I would like to do is try to get through the calculations part. So do I have your attention for like the next 10 to 15 minutes? Okay. So let's take a look at an example. In many games rolling dice, rolling a 6 is desirable. The probability of rolling a 6 when rolling a fair die is 1 out of 6. Let x be the number of 6s in 4 rolls of a fair die. If that's the case, x is binomial with n is equal to 4 and p is equal to 1/6. So first we're going to calculate what is the probability that x equals 0. So what that means is out of 4 rolls, we get 0 6s. Well, if we've rolled 4 times and we got 0 6s, that means all 4 rolls are not 6s. So what is the probability of not a 6?
5 out of 6.
5 out of 6. They're independent, so we can take it to the 4th power for all 4 rolls. All right, 5 out of 6 for the first roll, 5 out of 6 for the second roll, so on and so forth. That gives us about 0.482. Okay, so then a probability of 1/6 means out of 4 rolls, we get 1/6, which then, of course, means 3 that are not a 6. So the probability that we get a 6 is 1/6. The probability we don't get a 6 is 5 out of 6, but we have to raise it to the 3rd power because that's happening 3 times. This is not the full probability, though, or the full calculation. And why is that? Yara?
They could happen in like different orders.
Okay, it can happen different ways. Thank you. So if I roll 4 times, the 6 could happen here, or here, or here, or here. There's 4 different possibilities, so I have to multiply by 4. So this is about 0.386.
Yes.
Okay. We're not going to do 2, 3, and 4. We're not going to do all of them. We are going to do 2, though. So 2, again, means 2 6s. 2 that are not a 6. So our 2 6s would be 1/6 squared. Our not 6s would be 5/6 squared. But then this is where we have to figure out how many ways it can happen. So if I have 1, 2, 3, 4, a lot of possibilities. I could get a 6 and a 6, a 6 and a 6, 6 and a 6, a 6 and a 6, a 6 and a 6. So that's 1, 2, 3.
Blank 6.
Yeah. Blank, blank, 6, 6. 1, 2, 3, 4, 5, 6.
I know. 6. Not 6, not 6. Yes.
Okay.
I think that's
So 1, 2,
all the
3,
possibilities.
4, 5,
So I
6.
think you
7.
actually copied one.
I copied one. I think I did too. So there are 6 possibilities. So we would multiply it by 6. Okay. Now, this is obviously not efficient. It is not efficient to try to figure out how many ways there are, particularly if we have more than 4 times we're doing something. But hopefully, this leads us to the general way that we can calculate these probabilities. So it's the number of possibilities, so like our 4 and our 6. And then we have our probability of success to however many we're looking at. So above, it was 6 possibilities. It was 1/6 squared. And then the 5/6, that was our failure. So that was 1 subtract the probability of success. So that was our 5/6. And the way we got that 2 is however many trials there were, we subtracted the number of successes. So all I did was take this up here, took the numbers, put it into symbols. Okay, this is not how it's going to show up on the formula sheet, though. It's going to look a little bit different, right? Because on the formula sheet, I can't write out number of possibilities, right? How do we actually calculate that? using a calculator instead of just writing out all the possibilities. So on the formula sheet, it's going to say the probability that x is equal to k. So in our case, k would be 2 successes. Number of possibilities is n choose k. N choose k. This is not a fraction. Notice I did not put a bar. This is not a fraction. This is something on your calculator called a combination. We're not going to calculate it because you don't need to know it. And then we have p to the k and 1 minus p to the n minus k. That is what is on your formula sheet. Here's what is important. You need to be able to recognize the formula. You do not need to use it, but it comes up in multiple choice sometimes. So you need to be able to recognize that formula. If I give you an example like this. Ten choose 2, 0.8 squared, 0.2 to the 8th. You need to be able to tell me what that means. Okay, take 20 seconds, talk to the person next to you. Tell me what information you can pull from what I wrote in green. Thank you. Okay, what does that information tell us? What's the 10 mean? What's the 2 mean? The 0.8, the 0.2, anything, Kyle?
There was 10 trials and 2 of which were successful.
Beautiful, thank you. 10 trials, 2 successes.
What is the probability of success?
Great, thank you so much. So there are 10 trials. We're calculating the probability of 2 successes, and the probability of success is 0.8. That's what I need you to be able to recognize. I'm not going to ask you to use the formula. I'm just going to ask you to recognize it when it comes up on multiple choice. Okay. Last thing I want to calculate. I want to do this last example to show you the calculator, and then we're done. Is that okay? Okay. In roulette, 18 of the 38 spaces on the wheel are black. Suppose you observe the next 10 spins of a roulette wheel. What is the probability that exactly 4 spins land on black? So you know this is binomial since we're talking about binomial right now. If we weren't doing that and this is in the future, what I see in my brain is 10 spins and I say, ooh, that's a fixed number of trials. And then I see if I'm spinning and all I care about is it black? Fixed number of trials, binary. To me, that says, yep, this is binomial. Right? All we care about is black, not black. The spins are independent. We're looking at a fixed number of trials, and we care about how many of them land on black. So we would say this is binomial. N is 10, and P is 18 out of 38. So in part A, we are looking for what is the probability that x is exactly 4. Because we've written binomial n and p, we don't need to use this formula. We've already shown work. We now can go to the calculator. Binomial is a type of distribution. So it's in the calculator, it's going to be under the distribution menu. So go to second distribution, and you should see binom PDF and binom CDF. So second distribution, do you see those two? You might have to scroll down a little bit. Binom PDF, binom CDF.
Yep.
Okay. So here is the difference. PDF is a single probability. CDF stands for cumulative. And when we say cumulative, we mean less than or equal to. So we want a specific probability for, we don't want something cumulative. So we're going to do binom PDF. When you click that, Does your calculator ask you for specific things, or is it just blank? It
Mine
asks
asks-
you?
it
Does
asks us for
everybody's
things.
ask?
Yep.
Mia, does yours ask? Yeah. Yours? Does yours also ask? It does. Everybody's does? Yours doesn't. Okay. So yours, it's always going to be the same order, and if you put it in the wrong order, it's going to give you an error. It needs the parameters first. So first you're going to put n. So you're just going to put 10 comma. Then it's going to need p. So you all should be doing this right now with me. Again, you're not putting the n equals, you're just putting trials 10, probability 18 out of 38. And then it will need x, which is 4. And when you hit enter, it should give you about 0.225.
If
Does it? This is considered showing work. Let me tell you one last thing. Did you get the same answer? If you like writing this out, which I know some of you do, technically College Board will accept that as work as long as you have those numbers labeled. So if you write n equals 10, p equals 18 out of 38, and x equals 4, College Board will give you credit. So if you're going to write out Binomial PDF, label your numbers. Questions, comments?